Have you ever wondered how Kubernetes manages its resources? Today, we're stepping into the intriguing world of Kubernetes, a platform that's shaking up the way we think about managing applications at scale. In the vast expanse of the digital universe, Kubernetes is like the captain of a colossal interstellar spaceship. Its mission to ensure that every application on board runs smoothly, efficiently, and without interruption. It's a complex task, but Kubernetes handles it with finesse, navigating through the challenges of scalability and efficiency like a seasoned spacefarer. So, what is Kubernetes? It's an open-source container orchestration platform designed to automate the deployment, scaling, and management of applications. In simple terms, it's the control center of your application environment, ensuring that all parts work together in harmony. Why is Kubernetes important? Well, in the modern digital age, applications aren't just standalone entities. They're made up of multiple, interconnected components, each with its own specific role. Without a system to manage these components, things can quickly become chaotic. That's where Kubernetes steps in, bringing order to the chaos and ensuring that every component performs its role effectively. But Kubernetes isn't just about management, it's also about efficiency and scalability. With Kubernetes, you can ensure that your applications are always running at their peak performance, no matter how much traffic they're handling. If a component fails or becomes overwhelmed, Kubernetes can quickly replace or replicate it, ensuring that your applications remain available and responsive. Moreover, Kubernetes brings a level of flexibility that's unmatched in the world of application management. It allows you to run your applications on any platform, whether it's a private data center, a public cloud, or even a combination of both. This cross-platform compatibility makes Kubernetes a versatile tool for any organization, regardless of its size or industry. To understand Kubernetes better, let's dive deeper into its fundamental components, nodes and pods. Join us as we journey into the heart of Kubernetes, exploring the intricate workings of these key elements and uncovering the secrets of this powerful platform. Buckle up, because it's going to be an exciting ride. So, what exactly is a node in Kubernetes? Well, let's dive right into it. Picture a node as a worker machine in the Kubernetes ecosystem. It's like a busy bee, buzzing around, doing all the heavy lifting, making sure everything runs smoothly. Now, a node could be a virtual machine or a physical computer, but what matters is that it has the necessary services to run pods, which are the smallest deployable units in Kubernetes. But we'll delve into pods more in the next scene. Each node in Kubernetes is like an individual player in a grand orchestra, performing its part to keep the symphony of your applications harmonious and in tune. But what makes up a node? What are its components? First, we have the kubelet. This is the primary node agent that Kubernetes uses to communicate with every node. The kubelet is like the conductor of our orchestra, ensuring all the musicians, or in this case pods, are in sync and playing their parts correctly. Next, we have the kube proxy. It's a network proxy that runs on each node, taking care of the network routing for TCP and UDP packets. The kube proxy is like the stage manager, ensuring all the technical aspects run without a hitch, allowing the performance to shine. Finally, we have the container runtime. This is the software responsible for running containers. You can think of it as the stage itself, providing the platform for the pods to perform their tasks. Together, these components form the node, a critical part of the Kubernetes ecosystem. The node takes the instructions from Kubernetes, deploys the pods, and ensures they're running as expected. It's a powerhouse, tirelessly working to keep your applications up and running. In essence, a node is a powerhouse that runs your containers and manages the Kubernetes ecosystem. It's the worker bee, the orchestra player, the stage manager, and the stage itself, all working together to ensure your show goes on. Now that we understand nodes, let's decipher another critical component, pods. In the grand scheme of Kubernetes, pods are the smallest and simplest unit in the Kubernetes object model that you create or deploy. It's like the basic building block of Kubernetes, the atom if you will, but don't let its size fool you. Even though it's the smallest unit, it's packed with functionalities that are vital to Kubernetes operations. So, what exactly is a pod? Imagine a pod as a group of one or more containers that share storage and network resources and run on the same node. Each pod is meant to run a single instance of a given application, thus representing a single running process on your cluster. A pod's containers are always co-located, co-scheduled, and run in a shared context. This shared context allows the containers in a pod to share the same IP address and port space and can communicate with one another using localhost. They can also share storage volumes, which allows data to be quickly communicated between containers. You might be wondering, why not just run each container independently? Well, that's a valid question. The reason is, by grouping related containers together into a pod, Kubernetes allows you to manage, deploy, and scale them as a single entity. This is much simpler and more efficient than dealing with each container individually. So how does a pod come into existence? Well, typically, you don't create pods directly. Instead, you create them indirectly by deploying what's called a workload resource, such as a deployment or a job. These workload resources define your application's desired state, and the Kubernetes system takes it from there, creating pods as necessary to match that desired state. To sum it all up, a pod is like a personal workspace for your containers. It provides the runtime environment where they live and work together, sharing resources and dependencies. It's like a well-oiled machine with all its parts working in harmony. In short, pods are the heart of Kubernetes operations, encapsulating application containers and storage resources. With a good understanding of nodes and pods individually, it's time to see how they work together in the Kubernetes ecosystem. In the grand scheme of Kubernetes, these two elements form an intricate dance, each playing their part to orchestrate an efficient, scalable system. Let's imagine the Kubernetes system as a thriving metropolis. Nodes are the buildings, the infrastructure that houses the hustle and bustle of the city. They are the physical or virtual machines running Kubernetes, providing the necessary resources and environment for your applications to function. Pods, on the other hand, are the inhabitants of these buildings. They are the smallest, most basic deployable units in Kubernetes, each encapsulating an application container. A pod is self-contained with its own storage resources and unique network IP, and it can consist of one or multiple containers that are tightly coupled and share the same lifecycle. Now, how do nodes and pods interact in this cityscape? Think of nodes as landlords, managing the resources for the pods they accommodate. A node can host multiple pods, with the exact number depending on the node's capacity and the requirements of the pods. The pods live inside the nodes, running their containers and executing their processes. But nodes do more than just provide a home for pods. They also monitor the pod's health, restarting or rescheduling them if they fail. Nodes manage the pod's resources, ensuring that each pod gets its share of the system's CPU, memory, and storage. They interact with pods to execute processes, manage resources, and maintain the overall health of the system. In this way, nodes and pods form a symbiotic relationship. Nodes provide the environment and resources for pods to function, while pods execute the processes that make the Kubernetes system operational. It's a delicate balance, but one that Kubernetes manages with exceptional efficiency. As you can see, nodes and pods have a symbiotic relationship, together forming the backbone of the Kubernetes system. Let's recap what we've learned about nodes and pods in Kubernetes. We traversed the intriguing world of Kubernetes, a powerful system designed for managing containerized applications in a clustered environment. We broke down the concept of nodes, the worker machines in Kubernetes. Each node is like an individual gear in a grand machine. It's a worker machine that could be either a physical or virtual machine, depending on the cluster. Each node contains the necessary services to run pods, which are managed by the master node. These services include Kubernetes, an agent that communicates with the master node, Kube proxy, a network proxy reflecting services as defined in Kubernetes API on each node, and a container runtime, like Docker, which is responsible for pulling the container image from a registry, unpacking the container, and running the application. Then we unraveled the mystery of pods, the smallest and simplest units in the Kubernetes object model that you create or deploy. A pod encapsulates an application container, or in some cases, multiple containers, storage resources, a unique network IP, and options that govern how the containers should run. Pods represent a single instance of a running process in a cluster and can contain different containers that are tightly coupled and need to share resources. We also explored how nodes and pods work together. Nodes serve as the worker machines that host pods. Each node can host multiple pods, and the Kubernetes master automatically handles scheduling the pods across the nodes in the cluster. This is crucial for load balancing and ensuring that applications remain available even if some nodes fail. With the knowledge of nodes and pods, you are now equipped to navigate the Kubernetes landscape more effectively. Remember, every big journey starts with small steps. Today, you have taken a significant step in understanding the world of Kubernetes.